Hello everyone, welcome to the Gate Academy. I hope you all are well and safe at the home, isn't it? So please respond. So as you know, in this session, we are going to discuss about those topics which have recently added in the syllabus of engineering mechanics for GATE 2021. Fine. So today we are going to discuss about those topics. And as you know, the importance of the concept of the friction, because in previous year examination, number of questions have been repeatedly asked from this topic. So good morning, Vinay. And so as you know, what is the importance of this friction? So as per seeing the importance of this concept, GATE recently added the application of this concept of friction to the problems, that is the application of friction. So finally, in this session, we are going to discuss about the concept of friction and how we can use that concept of friction to the problem of that is related to the application part of the friction. Fine. So in this session we are going to discuss about that topic, and as you know that this is very important topic, so please stay with this session up to the last, because only this session will help you a lot, and by seeing this session only you can easily score the marks from this topic. Fine. Okay, so if you see that this session is helpful for you, so please share this session with your friends also. Fine. Okay, so first I will tell you about myself. Who am I? So myself, Vikalp Tiwari, and I am the subject matter expert at the GATE Academy for the mechanical engineering. Fine. And I have 3+ year teaching experience, and this is enough for me. So right now we are going to start about the topic that we will cover in today's session. Fine. Okay. So as you know, the topic which have recently added in the GATE syllabus. So can anybody tell me what are the topics have been added for the engineering mechanics syllabus? Anyone? Which topic have been added for mechanical engineering in engineering mechanics syllabus? Please respond, because when you will respond, then I will understand your doubt, that where you are facing doubt, and you feel free to ask the doubt. Fine. So wherever you are facing problem, you may raise your doubt in the comment box. Fine. And I will resolve here. Fine. Okay. So can anybody tell me what are the topics have been added for engineering mechanics for GATE 2021? Belt and pulley friction. Very good, Krishan Bansal. Very good. And so first topic is what? So I am writing here. So first topic is these topics are the parts of application of friction. So I am writing a heading, application of friction. Fine. So what are the topic? So I am writing here one by one. So as Krishan Bansal said, that first topic is belt pulley friction. Very good. Belt pulley friction. And what about the another topic? Yes, brake clutches. But Krishan, the brake and clutches, this is also a part of machine design. So this topic you will cover in machine design portion. Fine. So here we will cover only those topics which you do not cover in any other subject. Fine. So first one is belt and pulley, because this is not the part of GATE syllabus previously. And the second portion is screw jack. So I hope you all are aware with this topic, screw jack. But previously this topic was not in the GATE syllabus. I hope this topic you have studied at your graduation level. Fine. Now, so what is another topic? That is the application of friction. So we will discuss about the wages also. Fine. Wages, and there is one more topic that is completely different. So that topic name is one more topic, that is Lagrange's equation. Lagrange's equation. So actually in this session only we will see what are the Lagrange's equation and where we can apply and how we can apply the Lagrange's equation to the dynamic problem. So please be with the session and share this link with your friends so that they can also learn this concept, because this is a very important topic, friction, and you have seen this topic is many times asked in the previous year examination. So right now they enlarge that topic, they increase the width of this topic, friction. Then so it is sure shot that in either in this year or in upcoming year you will see a question from this topic. Fine. So this is very important. Fine. So right now we are going to start about this topic. So before starting the topic, as you know, these all topics are based on the application of friction. So what we will do, first we will see a little bit about this term, that is friction, and later on we will see that how we can apply the concept of friction to the problems that is related to the belt, pulley friction, screw jack, and the wages. Is it okay? So please respond yes or no. Fine. Yeah, Kapil Pat. Okay. So first we are going to start. With concept of friction. Fine. I'm facing problem. Please wait a little bit. My computer is hanged. Yeah. Now it is okay. Fine. So right now we are going to start with concept of friction. Fine. Okay. So can anybody tell me what is the friction? Because this is a very important concept, and I hope this concept you have studying from the 5th standard. Fine. So can anybody tell me what is the friction? Anyone? What is the friction? Please respond, each and every person. What is the friction? Yes is asking, sir, is it the first lecture? Yes, this is the first lecture. Fine. And this lecture is only for mechanical engineers, because the topic which are going to discuss, these topics are added in the syllabus of mechanical engineering. Fine. So this topic is for mechanical engineers only. So when I saying it is a opposing shear force, so it is the opposing shear force, and but when I is saying it is the opposing shear force. So very good. And anybody can tell me Any more explanation about the concept of friction? What is the friction? Resistance to the motion of body offered by any frictional surface in contact. Very good, yes. So the actual definition is what? As you know that friction is what? It is a type of contact force. It is a type of contact force. So that means this force will only develop at the contact surface. So what is the friction? So friction is defined as it is a force. It is a force. Sorry. Now what is the first term? So first term is what? When a body either is in motion, when a body either is in motion or it have the tendency of motion. So this is important also, because if the body is only in rest, it is not having the tendency of motion, then there will be no friction. So friction will come into picture when the body is either in motion or it have the tendency of motion. In that condition, what will happen? Due to the surface, due to this surface, a resistance force is developed. Due to this surface, a resistance force is developed at the contact surface, and this resistance force is known as the friction force. This resistance force is known as the friction force. As you know, in this condition, because there is no force, that means there will be no tendency. So when we will apply a force, then it will have the tendency of motion. That means correspond to the force, any applied force P only, there you will see a friction force. Is it okay? So this is the friction force. Any doubt in this? You may ask if you have any doubt about the concept of friction or the definition. Yeah, Mukesh is saying friction is the opposite motion comes to play when there is a relative motion. Yes, Mukesh, but it is for the friction, it is not necessary that there should be relative motion. If even there is a tendency of relative motion, then also the friction will come into the picture. Is it okay? Rutik, friction is a surface force which tends to opposite relative motion. Very good. So I hope the concept of friction is clear to all of you. So right now we are going to discuss about the type of friction. Fine. So what is the heading? Next heading is type of friction. Type of friction. So can anybody tell me what are the types of friction? Please respond. What are the types of friction? What are the types of friction? Okay, very good, Muhammad Jahid. So the type of friction is what? So there are basically two types of friction. First one is the static friction. Static friction. And second one is kinetic friction. Second one is kinetic friction. So Hers is saying that there is rolling friction and sliding friction. Hers keep a note that whenever we simply denote the friction term, so friction simply means we are talking about the sliding friction only. Whenever simply friction is mentioned there, that means we are describing about the sliding friction only. Fine. So here we are discussing about the type of sliding friction, because the concept of rolling friction is completely different from the concept of sliding friction that we will discuss in this class only. Fine. So here we are discussing about the type of sliding friction. So sliding friction are of two types. First one is the static friction and second one is the kinetic friction. Is it okay? Any doubt, Hers? Fine. So now what is the static friction? So static friction is what? Static friction is what? Can anybody tell me what is the static friction? So static friction is here the term static means when the body is at rest, but there should be tendency of motion, because if there is no tendency of motion, then there will be no friction. Fine. So static friction will when come into picture. So static friction will come into picture when the body is at rest, but there is a tendency of motion. Fine. Sorry. There is a tendency of motion. So in that condition, whatever friction acts on the surface, that friction is known as the static friction. And if we are talking about the magnitude of static friction, so I hope you all are aware about this concept, that the magnitude of static friction lies in between 0 to μs into n. So static friction is self-adjusting in nature. So this is a very important point for static friction. It is self-adjusting in nature. And what about the self-adjusting? With what it is self-adjusting? So it is self-adjusting in nature with respect to what? With respect to applied load. That means whenever the body is in rest, and there will be a tendency of motion, in that condition, the magnitude of static friction will be equal to the applied load. In that condition, the magnitude of static friction will be equal to the applied load. For example, there is one body, and the surface can offer a maximum resistance of, that is µs into n. Its value is 10 Newton. Then what will happen? If you are applying a force of 1 Newton, then what static friction you will get? Tell me. If you are applying a force of 1 Newton on this block, then what amount of friction you will get on the block due to the surface? Anyone? Can anybody tell me? In that condition, what will be the magnitude of static friction? Because correspond to the force of 1 Newton, there will be a tendency of motion of this block. So block is at rest and there is a tendency of motion. That means whatever friction will be there, that will be the static friction. But what is the magnitude of that friction? I am waiting for the answer. Please respond. So the friction in that condition will be equal to, because it is self-adjusting in nature. If you will apply a force of 1 Newton, then it will offer a resistance equal to 1 Newton. When you will apply 2 Newton, you will get a friction equal to 2 Newton. And up to when you reach the maximum value of static friction, it will offer the same resistance as equal to the applied load. Whatever load you will apply, the same resistance it will offer to the body. Fine. So these are the properties about the static friction. I hope this term is clear to you. Fine. So is there any problem with this concept? Okay. So now we are going to discuss about the kinetic friction. Can anybody tell me what is the kinetic friction? What is the kinetic friction? What is the kinetic friction? It is very simple. When the body is at rest, then it will be the static, because kinetic means body is in motion. Kinetic term represent it is the condition when the body is in motion. So when the kinetic friction will act, when the body is in motion. So whenever the body is in motion, in that condition, the resistance offered by the surface to the body is known as the kinetic friction. And what about the magnitude? So magnitude of kinetic friction is constant. So magnitude of kinetic friction is constant and its value is equal to mu k into n. And it is always constant in nature. Fine. Is it okay? So I hope this concept about the friction is clear to all of you. Is there any problem? If you are facing any problem with the concept of friction, then you can ask your doubt in the comment box. Fine. Okay. Now, so the concept of friction is over here. Now we will discuss about the rolling friction. Rolling friction. So what is the rolling friction? Hers, whatever you are explaining that there is a rolling friction. So can you please explain what is the rolling friction? Anybody? Can you explain what is the rolling friction? Because the concept of rolling friction is different from the concept of sliding friction. Fine. So in right now we will discuss about the rolling friction also. Anyone? I am waiting for the response. Please respond, because whenever you will respond, then I will get to know that where you are facing problem. Fine. Point contact. So hers is saying it is a point contact. Okay. But how the rolling friction is related to the point contact? Anyone? Okay, no problem. I will explain here what is the rolling friction. So what is the rolling friction? It is the wall is rolling on the floor. Hers, exactly. When wall is rolling on the floor, then there will be rolling motion. But how you can explain that what is the rolling friction? Nihant is saying the friction occurs when the object is rotating. Are you talking about rotating or rolling? Nitant. Muhammad Zahid is saying resistance offered when a body rolls over a surface. Very good, Muhammad Zahid. And Nitant, it is not rolling. It is not like rotating, because you know that rotation is different and rolling is different. Fine. So rolling friction will come into picture when the body is rolling over the surface. So what is the rolling friction? I am explaining here. Please see here. Fine. So what is the rolling friction? It is the resistance to motion. It is the resistance to motion when a body rolls over the surface. So now what is the rolling friction? So whenever a body rolls over a surface, in that condition, whatever resistance you feel, that resistance is known as the rolling friction. As already I have discussed about that concept of rolling friction is different from the concept of sliding friction. Because how it is different? So just tell me one answer. For example, let us there is one surface and our disk is rolling on that surface. Our disk is rolling on that surface, fine, and this disk is in pure rolling motion. So this disk is in pure rolling motion, fine. So pure rolling is, you can say that rolling without slipping. Is it okay? Rolling without slipping. So it is rolling without slipping. Can anybody answer when a disk is in pure rolling motion over a surface in that condition? Because in that condition there is a point contact between the body and the surface. Can anybody tell in that condition what will be the magnitude of sliding friction at point of contact A? So right now I am interested to know what is the magnitude of sliding friction at point A. I am waiting for the response. Please respond. What will be the magnitude of friction when a body is in pure rolling motion over the surface? 0. So when I am saying 0, very good. So in that condition, the magnitude of friction, sliding friction will be 0. Why it will be 0? Because it is mentioned here when the body is in pure rolling motion, in that condition, it is also known as rolling without slipping. That means there is no relative motion between the surface and the body. So if there is no relative motion, that means there is no tendency of motion. So if there is no tendency of motion, then there will be sliding friction is equal to 0. But still in that condition, you will still in that condition, you will feel a resistance. That resistance only is known as the rolling friction. But right now you are interested to know, sir, what is the reason behind that rolling friction? Fine. So actually the cause of the rolling friction is nothing but it is the non-elastic effects. It is the non-elastic effects. So the reason behind the sliding friction is what? Reason behind the sliding friction is what? That is the surface irregularities. But what is the cause behind the rolling friction? So that is nothing but the non-elastic effect. Now what is the non-elastic effect and why the rolling friction will come into picture? So as you know, all bodies are elastic in nature, or we can say that whenever a force is applied over a body, in that condition that body suffers through an amount of deformation. For example, here we are taking two surfaces. First one is the surface of body and second one is this horizontal surface over which the body is moving. So let us assume in that condition either the body is soft or we are considering this surface is soft. Whatever you will see, I will take that example. So please respond in chat. Whatever you want to take, we will consider the body as a soft or the surface as soft. Because obviously both the bodies will be soft, or there will be a tendency one body is soft. Okay, so yes is saying please consider body as soft. Okay, so if the body is soft and the surface is hard, in that condition what will happen? So as you know, because the body is soft, so what will happen? Sorry. Okay, so what will happen if the body is soft? In this condition, the body will deform at the contact surface. Because why? The surface is hard and you are applying a amount of load W on this body. So due to its weight, or you can say that whatever weight it is carrying, so due to that weight, due to that load, what will happen? The pressure at the contact surface causes the deformation in the body. So the surface, this curvature will convert into a form of some straight line. So we can say that in that condition, at the contact surface, the body is deformed. So when the body is deformed, whatever you see there, so what you feel there, in that condition, you will see that there will be a contact force like this. And as you know, contact force have two components. First one is the normal reaction, and second one is what? Second one is the horizontal component. So in that condition, when the deformation will occur at the contact surface, so this is the normal reaction. So if this is the normal reaction, this is the resultant force. So the component of resultant force normal to the surface is known as the normal reaction, and this contact force will have one horizontal component that is opposite to the direction of motion. Because if the body is moving in this direction, then you will see a contact force in this direction, and the component of this resultant force opposite to the direction of motion, this force is called as the rolling friction. This force is called as the rolling friction. Even we may consider the second case also. For example, the surface is soft. So what will happen? The body will not deform. In that condition, what will happen? The surface will deform. So as you can see, because this is the body, and here I am highly exaggerating this scenario. So in that condition, what you will find, this is the weight. This is the weight of the body, and due to the weight of the body, there will be some deformation inside the surface. So you will see the contact force something like this. So this will be the normal reaction due to that contact force, and there in this direction there will be a resistance offered. There will be a resistance offered. So this force is known as the rolling resistance. This force is known as the rolling resistance or rolling friction or rolling drag. So right now I am here writing all the name. So it is also known as rolling friction. It is also known as rolling resistance. Rolling resistance. Rolling resistance. And it is also known as rolling drag. Is it okay? Also known as rolling drag. So what is the cause behind this rolling resistance? The cause behind this rolling resistance is what? Non-elastic effects. And I hope this concept is clear to you. If it is not clear, then we will take one example, and this example will make a clear picture about the rolling friction. Is it okay? And with that concept, we will also discuss one more definition about the rolling friction. Fine. Okay. So now there is a question for you. For example, there is one surface. There is one surface. This disc is in pure rolling motion. This disc is in pure rolling motion, and at any instant, this disc have v amount of velocity. Fine. So at any instant, this disc has v amount of velocity. Now pure rolling is set inside the disc. Now pure rolling set is inside the disc. Pure rolling is set inside the disc, and as you know, in that condition, at point of contact, there will be zero friction force, zero sliding friction force. So F at point A is equal to 0. Now there is one question. As you know that F is equal to m into A. Is it okay? Any doubt? Because this is a Newton's law, and I don't think that there will be any doubt. Fine. So as you know, whenever there will be a resultant force, your body will accelerate. Fine. And if there is no force, then acceleration will be is equal to 0. Then means you can say that the velocity will be constant. So from here you can conclude that there is a requirement of force only in order to accelerate the body. In order to move a body with a constant velocity, there is no requirement of force. Are you clear with this term or not? Is there any doubt regarding this concept? I don't think that there should be any doubt regarding this concept. That means in order to accelerate a body, there is a requirement of one force. In order to move with a body with a constant velocity, there is no requirement of any force. Fine. Now see here. For example, the body is in pure rolling motion. The body is in pure rolling motion, and body is moving with a velocity v. Body is moving with a velocity v, and at the point of contact, there is no friction. So just tell me, if at any point it has a velocity v and there is no sliding friction, then what will be the position, what will be the condition of this body after a time of 10 minutes? A disc is rolling with a disc was rolling with a uniform velocity, and it is in pure rolling motion. And I just want to know, because we are starting the motion with a v velocity. Fine. And after that, there is no force is acting that is responsible for the motion. So I want to know what will be the condition of this body after 10 minutes. Will it be stopped, or it will move with the same velocity? What will happen? I am talking about the real scenarios. Fine. What will happen? Because there is no friction. That means due to the sliding, there is no resistance, and it has some velocity. That means it has some kinetic energy. So what will happen after 10 minutes? it will continue to move with the same velocity. Yes, I am talking about the real scenarios. I am talking about the real scenarios, not ideal scenarios. Fine. Because you have seen, once you have, so for example, there is one coin and you are dropping this coin over a height on this surface. So what you will see after some time, what you will feel that pure rolling is set into this coin. After some time, what happens? Pure rolling is set into this coin, and before when the pure rolling is set into the coin, there will be some magnitude of sliding friction. But when the body is set into pure rolling motion, in that condition, you know that there is zero static friction. Sorry, there is zero sliding friction. But I think you have seen that the coin will come to rest after some period of time. Why it is happening? Because there is no friction is acting, then it should continue its motion, na? But why it is happening that the body stops after some period of time? So the reason is what? Reason is nothing but it is the concept of rolling resistance. Because whenever a body is in pure rolling motion, even there is no sliding friction. But because of non-elastic effects means at each point of contact, because you can observe at each instant of time, point of contact is changing. If the point of contact is changing, that means at each instant of time, different point will deform. So the kinetic energy of that body will go into the deformation, and after a period of time, what will happen? The complete kinetic energy is consumed into the deformation, or in some hysteresis losses, or in permanent deformation. So this is the concept behind the rolling friction. So it do not depend upon the surface irregularities, it depends on the non-elastic effects. Is it okay? I think this concept is clear to you. Fine. So if we are talking about, if we are interested to calculate the magnitude of rolling friction. So in analogy with a sliding friction, the formula of rolling resistance is what? So actually there are two concepts. The rolling resistance is defined in two ways. First one is mu r into n. Now, so sometime you will see that the unit of this rolling resistance is given in mm. Sometime you will see that the unit of this rolling resistance is given in mm, and sometime you will see that this mu r is given a unit less quantity. So what will be the formula? Whenever you will see that it is given in mm, in that condition, what will be the formula? The formula will be something like this: mu r divided by radius of that disc into n. And n is what? N is nothing but n is the weight of that body. Fine. So n is what? N is the weight of that body. This formula you will use when unit is given in mm. And it is also known as coefficient of rolling resistance. And it is also known as contact length. Sometimes you will see that contact length is given. What is the contact length? So see here, the distance from the center of this disc to this point. This length is known as the contact length. Fine. So if diagram is given, then this term will be equal to A or mu r will be equal to A, that is the contact length. Fine. So if the formula is given, if the rolling resistance unit is given mm, then you will use this formula. And if it is a dimensionless quantity, then Fr you will use mu r into n. N is what? That is nothing but the weight of the body. Fine. So this is what? This is nothing but it is the rolling resistance. And with this concept, you can calculate the magnitude of rolling resistance. Fine. Okay. So this is all about the rolling resistance. There is one more definition about which I have told that I will discuss in this after this concept only. So what is the next? What is another definition of rolling resistance? So another definition of rolling resistance is it is a horizontal force. It is a horizontal force. It is a horizontal force that is required. That is required to move our body. To move our body. Sorry, to roll our body. That is required to roll our body with uniform velocity. That is required to roll our body with uniform velocity. So when the body is in pure rolling motion, in that condition also, even there is no sliding friction, but in that condition also you will feel one resistance. So if you want to and correspond to this resistance, what will happen? The body will retard. So if you want to roll a body with a uniform velocity, so in that condition, you will have to apply a force. You will have to apply a horizontal force, and magnitude wise, these two terms will be equal. So how it is defined? It is a force that is required to roll a body with a uniform velocity. Fine. Is it clear to all of you? So please respond yes or no. Is there any doubt? Or we can start the next topic, that is the application of friction. Any doubt? Okay. So I hope there is no doubt. I am mentioning here when mu r is unitless. Okay. Fine. If it is clear to all of you, then we are going to the application part of the friction. So what is the first application problem? So here we are going to discuss about the wages. Can anybody tell me what is the wage? Wage. Anybody? What is the wage? Okay, no problem. I am discussing here what is the wage. So wage, it is a device. So Christian is saying it is a triangular block. Very good. And 385 Kiran is responding that it is the incline support. Very good. So actually, what is the wage? I am defining here. It is a device that is used. It is a device that is used to lift a load for a small distance, or to lift a load for a small distance, comma, sorry, to lift a load for a small distance and to separate the two bodies, to separate two bodies, and for slight adjustments, adjustments. Fine. So vase is what? It is nothing but it is a piece. It may be a piece of metal, or it may be a piece of wood that is used to lift the load, that is used to lift a load for a small distance. Either it is used for lifting a load for a small distance, or it is used to separate two bodies, or it is used for the slight adjustment. So right now I am drawing here. What is the vase? So such type of metal or wooden block, either it may be like this, or it may be like this. That means either it can be triangular in shape, or it can be a trapezoidal in shape. So all such type of devices as I shown on the screen. So such type of devices which is used to lift a load for a small distance, or to separate the two bodies, or for slight adjustment, that device is known as the wedges. And if you are talking about how we can use this device for a small distance, so don't worry, we will take an example of the wedge to lift a body for a small distance. And if we are talking how it can separate two bodies, so for that I want to explain the concept. I want to explain the example of sword or knife. So in case of sword or knife, you have seen that the edges of sword or the knife is triangular in shape. Why it is triangular in shape? Because when the edges penetrate inside the body, then that wedge shape try to separate those two bodies. I hope you have seen that sword is used for breaking the wood. In that condition, what will happen? The sword is something like this. Fine. So this is the handle. In that condition, you have seen, if I will see the side view of this, so you will see it is something like this. The edge of the sword is something like this. So this is nothing but it is a wedge shape. It is a wedge shape that is used to separate the wood. Fine. And for slight adjustment, you have seen sometime you will see that some body is unbalanced. So in what condition, what you will do, you will take a small chip and place inside that body, and after that you will observe that body is now completely balanced. So for slight adjustment also a wedge shape is used. I hope you have already studied that when a gear is mounted over a shaft, so in that condition, inside the key slot, a key is inserted into the key slot, and that key is also either trapezoidal in shape, or it is triangular in shape. So when we will hammer that wedge shape body or metal or wood into that key slot, after that we will see that there is no relative motion in between the shaft and the gear. So in this way, the wedge can be used for the slight adjustment also. Is it okay? Fine. Now, here we are interested to do the analysis over wedges. So on which principle this wedge works? So right now I am discussing about the principle of wedge. So principle of wedge is nothing but it works. So what is the principle? So it works on the principle of equilibrium of inclined planes. Equilibrium of inclined planes. Fine. And one more important thing that you will have to consider in case of wedges, always when you will get a question of wedge, the condition of friction will be limiting friction condition. Always the problem of wedges deal with the limiting friction condition. Limiting friction condition means at each and every surface, the magnitude of static friction will be maximum. So whenever you will see that question is related to the wedge, then each and every surface you can consider that the static friction is what? Static friction is the maximum static friction or the limiting friction. That means body is just about to move or it is at the verge of motion. Fine. So now we will take one example, and here we will see how we can do the analysis over wedges. Up to now, is there any doubt? You can tell me. Or we can start, or please tell me if there is no doubt, then we can move forward in our session. So please respond. Is there any doubt up to now? Because this is a very new topic, because friction you have already studied, I know this, but the wedge concept, the belt pulley concept, and the screw jack concept, this concept is very new. So if you have any doubt, then you can ask here. So please respond, because whenever you will respond, then it will motivate me also. Fine, that you are interacting. Fine, very good. Yes. Okay. So when I say please explain the application of wedges in sword. So as I have already explained that wedge shape, sorry, that edge of the sword, is used to separate the two bodies. So that is the application of wedges in case of sword. Fine. So I hope you have seen that there is a wood block, and if you want to break into two pieces, then what you will do, you will strike the sword on this block. So what will happen in that condition? You will see such type of texture or such type of groove occurs in that wooden block. So after some time, when you will strike two to three more times, then you will see that this wooden block is broken into two parts. So that wedge is very helpful to separate the two parts. That is the application of wedges. Is it okay? Fine. So keep one thing in your mind, that in case of wedges, you are going to consider the limiting friction, and what principle you are going to use. The concept is nothing but it is the equilibrium of the inclined plane, and you have already studied about the equilibrium condition of a body. Can anybody tell me what is the condition of equilibrium for anybody? Anyone? And which condition we use in case of inclined planes when we used to solve the problem of friction that is related to the inclined plane? What are the conditions of equilibrium? Can anybody tell? Anyone? I am waiting. What is the condition of equilibrium? Yeah, sigma. When I is saying sigma fx is equal to 0, fine. But when I not sigma fx is the condition only. For a body to be in equilibrium, when we deal with the inclined plane problem, so the net force on the body should be is equal to 0. That means summation of fx should be is equal to 0, and summation of fy should be is equal to 0. So Parth is saying that tan alpha is equal to mu. So Parth, I want to say that this is not the correct answer, because tan alpha is equal to mu. This is the concept of angle of friction. Fine. So angle of friction is equal to the coefficient of friction. So I am not talking about the angle of friction. Here I want to know what is the equilibrium of inclined plane. So for any body to be in equilibrium, if it is not in rotation, then only the summation of the forces on that body should be equal to 0. Fine. So only these two conditions we are going to use here: summation of fx0 and summation of fy0. Now there is one more concept. There is one more condition that we frequently use in the problems of equilibrium. Can anybody tell me, apart from these two conditions, which equation you frequently use in your problems for the equilibrium condition? Anybody? I know in case of equilibrium problems, mostly you use summation fx0 and fy0, but you also use one equation, one theorem that is related to the problem of equilibrium of any body. Summation of movement is 0. Mohammed, as I already told you, because if the body is not in rotation, then there is no need to consider the movement. Fine. Lami's theorem, very good, Vinay. So apart from these condition of equilibrium, there is one more method for analysis of equilibrium problem. That is what? That is the Lami's theorem. Very good, Mohammed Zahir. That is Lami's theorem. What is the condition of Lami's theorem? When we can apply the Lami's theorem? When we can apply the Lami's theorem? So condition is that Lami's theorem is applicable only for 3 forces in equilibrium. Whenever only 3 forces in equilibrium, then we can use the Lamy theorem. If the number of forces more than 3, then we have to these condition of. Is it okay? Fine. Now, so right now we are going to see the wages problem and how we will solve the problem of wages. So see here. I am taking one example. So let us assume there is one vase. Fine. And if you feel any doubt, please ask. I will answer to that problem. Fine. So there is one vase and it is using for lifting this body. Fine. So the weight of the body is nothing but W, and on this left part there is a vertical wall. Fine. Up to here there is a vertical wall, and this wedge is placed over a surface. Fine. So you are applying a force of P here. Is it okay? And the angle of the base is what? That is alpha, and we are assuming that weight of this block is W. So what will happen? If we will apply a force P in leftward direction, then what will happen? This block will come downward. So if we are applying a force of P, in leftward direction, then what will happen? This block will come downward. So this block will come. Answer please. So what will happen if we will apply a force of P? So this block will come downward. Where it will come? Very good, Vinay. This will not come downward, because when you will apply a force in that condition, you will see that this inclined surface will exert a reaction force on that body, and due to this reaction force, what will happen? It will try to move the body in this direction, and it will apply a force in upward direction. So if the force on the body is acting in upward direction, so correspond to that force, this body will move upward, and correspond to this force, this body will try to move in leftward direction. But what is happening here? On the leftward side there is a wall, that means it is restricted to move leftward side, so the body will move only in upward direction. That means this direction is incorrect, so the body is moving in upward direction. Is there any doubt? Okay, very good. So this is the condition, and every time you will find such type of problem. Now, what is required? What will be asked in such type of question? So the question will be like this: what is the minimum force P? So the question will be like this: what is the minimum force? P that is required? To, this is body A, this is body B. What is the minimum force that is required to lift the body A in upward direction. Upward direction. Is it okay? Fine. So question will be like this: minimum, calculate the minimum force P. So as I have already told you, the question will always be related to the limiting friction condition. So he is asking what is the minimum force P, because as you know that when we will increase the magnitude of force after a certain limit, then also the body will move upward condition. But he is interested to know what is the least value of P correspond to that this block will move in upward direction. Fine. So how we can do the analysis of such type of problem that is related to the waves or the concept of friction. So now we will see how we can solve this question. Okay. So see here, please give your attention here. First we will draw the free body diagram. Fine. So if we are drawing the free body diagram, so this is the body 1, fine, and this is the body 2. Is there any problem? No. So right now I am going to draw the free body diagram. What is the free body diagram? Our body is detached from all the contact surface. This means this is a separate body, so I am detaching it the contact surface. So can anybody tell me how many number of contact forces are there in this complete system? How many number of contact forces, contact surfaces are there in given question? Anybody? Okay, very good. So everyone is responding 3. So that is the correct answer only. Fine. So here only three contact surfaces are there. That means it is very clear to us that there will be 3 normal reaction and 3 friction forces, because we are considering all the contact surfaces are rough surfaces. So we are assuming this is contact surface 1 and correspond to that friction angle is phi 1, or the coefficient of friction is mu1. This is the contact surface is 2, so the this is contact surface is 2, so the coefficient of friction is mu2 and the angle of friction is given phi 2. And for this surface, this is the surface 3, so correspond to this the coefficient of friction is mu3 or the angle of friction is phi 3. Any one value will be given to you, either the coefficient of friction or the angle of friction, because you know the relation between angle of friction and the coefficient of friction, and you can easily calculate that. Fine. Okay. Now, so how we can solve this question? So first we will draw the free body diagram. So identify the first force. So first is what? This is the force P. Is it okay? This is the externally applied force. Now we will draw the free body diagram at the contact surface. As you know, at the contact surface, 2 type of forces occur. First one is the normal reaction, and normal reaction always occur either the surface is rough or the surface is smooth. But the friction force will occur only when the surface is rough. So here all the contact surfaces are rough. That means at both the contact surface we will found 2 normal forces, normal reactions, and 2 friction forces. So as you know, if P force is acting in this direction, that means the tendency of motion of this block in this direction, that means friction on this surface will be in this direction. Is it okay? Any doubt? And what about the normal reaction? So normal reaction will be like this. And as you know, we always deal with the limiting condition. That means the friction force at this surface will act, that is nothing but 1 and 1. Any doubt? No, I don't think that there should be any doubt. Fine. Okay. So now what about the normal reaction? So we are considering at the surface the normal reaction is N1. Fine. Now, what about the surface? As you know, because when this body will move in upward direction, leftward direction. So in this condition, you will feel that there will be one friction force on this block, on this wedge in rightward direction, that will be inclined in nature. So this is the friction force at contact surface 2. Its value is nothing but mu n2. And what about the normal reaction? So normal reaction will be something like this. So it is n2. Fine. Now, how you can solve this problem? See here, very easy problem, and with this concept, you can solve any problem that is related to the wedge. So, what is the concept? In the problem of wedges, we will not deal with the friction forces and the normal reaction. We always deal with the contact force. Now, what is the contact force? So, contact force is nothing but it is the resultant of friction force and the normal force. So, as you know, friction is acting in this direction, normal reaction is acting in this direction. So, what is this? This is the line of action of this force P. Fine. And so what will be the resultant of these two force systems? So as you know, the resultant of these two force system will be something like this. So we will extend the line of action of this also. So as you know, these two forces will intersect somewhere here. Now, as you know, in this condition, the resultant of these two forces will be something like this. Now, just tell me what will be the condition of line of action of this resultant R2, from where it will pass, this point is, as you know, there is one force and we are assuming that there is one contact force that is developed here. So it is crossing the line of action of force P at some point O. So just tell me from where the line of action of force R2 will pass. Will it pass through O, or it will pass through somewhere, or it will pass through other than point O? Just tell me. It will pass through a point O, or it will pass through any other point other than O. Or if it is passing through point O, then why it is passing through point O? This is a concept only. If you understood this concept, then you can solve any problem of this wedge question. Then in that condition, you can solve any problem that is related to the wedge or the concept of incline. Pass through O, since the body is in equilibrium. Okay, so Muhammad Jahid is saying that it will pass through because the body is in equilibrium. Exactly. I hope you studied about the equilibrium condition for a body that is acted upon by three forces. So what is the condition of equilibrium that is acted upon by three forces? So condition is this: if a body that is acted upon by three forces will be in equilibrium if all the forces are concurrent. If all the forces are non-concurrent, then there is one more condition for the body to be in equilibrium, that the forces should be parallel. Only in this correspond to these two conditions only a body will be in equilibrium. Otherwise, for a three force, a body will not be in equilibrium. Apart from these two conditions, whatever condition of three forces is, the body will not remain in equilibrium. As you know, that line of action of force P is acting in this direction, and the resultant of these two forces will act in this direction. That means two forces are already concurrent. That means parallel force system cannot develop here. So from here we can conclude whatever will be the force R2, its line of action will pass through point O. Now, if this concept is clear to you, then you can easily solve any question. How you can solve easily any question? As you know, what is the angle of friction? So angle of friction is nothing but it is the angle between the resultant force and the normal reaction. So this is the angle of friction. Its value is phi1. It is already given. If it is not given, coefficient of friction is given. Then you can calculate phi1 from here, because tan phi is equal to mu1. In the same way, you can calculate the tan phi2. So how you can calculate the phi2? tan phi 2 is equal to mu2, and phi 2 is what? Phi 2 is nothing but this is phi 2. This angle is phi 2. So right now I am drawing here the diagram. This is force P, this is force R, this is force R1, and what about this force R2? So this is something force R2. So R2 is making phi 2 angle with N2, and what about angle with the vertical? So as you know, if this angle is alpha, then obviously this angle will be alpha. That means R2 is making an angle of phi 2 plus alpha with the vertical, and R1 is making phi 1 angle with the vertical. Is it okay? This angle is 90, this angle is 90, and this angle you can easily calculate. So here you can see one force is given. If one force P is given, then you can calculate the R1 or R2. If it is not given, P is required in the asked in the question, then what we will do in that condition, weight of block A will be given. So right now we will draw the free body diagram. Of this block. So how we can draw the free body diagram? As you know, weight will act here. So this is the line of action of the weight. At this condition, as you know, the normal force will act like this. Sorry, the resultant, this is the normal force. So this is going congested, so I am separating. Fine. Sorry. Okay. So the space is added here. Fine. So I am drawing the free body diagram. So as you know, the normal reaction will act like this. This is N2. Sorry. Normal reaction will be normal to the surface. So this will be N2. This will be the friction. This is mu N2. This will be N2. So the friction force will act something like this. Oh. So sorry. So the force is something like this. I am drawing here. Force is something like this. This is N2. So this will be the resultant. That is R2, and this R2, and this R2 will be equal in magnitude. Fine. So its line of action is passing through this point. So if its line of action is passing through this point, that means the resultant force on this point also, on this surface also will pass through this point. This is what? This is R3, this is R2, this angle is phi, this angle is alpha. Why? Because phi 2 is, because this normal reaction N2 is making alpha angle with the vertical. So here it will also make alpha with the vertical. This is phi 2. This is the angle between resultant and the normal. So here the angle between resultant and the normal, this is what? This is N3. This is mu N3, that is the friction. So angle between this is phi 3. And this is the point O. What about this point? This is the weight W. Just draw the free body diagram here. This is the weight W. This is one force R2. This is one force R2. This is one force R3. As you know, it is making phi 3 angle with the horizontal, and R2 is making phi 2 plus alpha angle with the vertical, and this angle is 90, and this angle will be 90 minus phi 3, and W. So from here, what you can calculate? You have two relation. Why? Because you can apply the Lamy here. I hope you can apply the Lamy here. If W is given, can you calculate the R3 and R2? Please respond. If W is given, can you calculate the R2 and R3? Because all the angles are given. Alpha is given, phi 1, phi 2, phi 3 is given. If W is given, can you calculate the R3 and R2? Fine. So you can easily calculate the R2 and R3. How you can calculate? With the concept of Lamy's theorem, or you can use the concept of equilibrium. For example, who are not familiar with the Lami's theorem, I am writing here the expression. So how you can write W divided by what? W divided by angle between these two forces. So these two forces what? Sine 90. Why? This is 90 plus phi 3 plus alpha plus phi 2. Is it okay? Any doubt? Now, when we are considering R2, fine. So sorry. This complete term I am picking from here. And is it okay? Fine. So now how we can write the for R2? So R2 will be equal to what? Can anybody tell me what will come in the denominator of R2? Anyone? Sine. If you can solve the problem, please respond. What will come in the angle of denominator of R2? Sine angle between other two forces. If you are considering R2, then what are other two forces? That is nothing but W and R3. So what is the angle between those two forces? That is nothing but 90 minus phi 3. 90 minus phi 3. Fine. And I think you can also calculate the R3. So R3 will be equal to sine angle between other two forces. So as you know, if you are considering R3, then other two forces are omega W and R2. So what is the angle? This is what? This is nothing but 90. This is phi 2 minus alpha. This is phi 2 plus alpha. That means this angle will be equal to what? 180 minus phi 2 plus alpha. Is it okay? So in this way, you can calculate what if W is given, phi 2, phi 3 alpha is given, then you can easily calculate the R2 and R3. This is one concept. Otherwise, what you can do, you can use the concept of equilibrium of forces. So how you can use? You will resolve the forces. That means I am writing here only one equation. In the same way, you can write another equation. For example, if I want to write the summation of fx0 here, so how you can write? You will write, we are considering this direction as positive. So you can write R3 cos phi 3, R3 cos phi 3 minus R2 sin phi 2 plus alpha. This is one equation. Fine. Now, what about the Fy? If you want to write Fy also, then how you can write? You can write in this way. How you can write in this way? So Fy, we are considering upward positive. That means it will be equal to minus W plus R2 cos phi 2 plus alpha. R2 cos phi 2 plus alpha minus R3 sin phi 3 is equal to 0. So this is the equilibrium of forces along vertical direction. Here W is given, phi 1, phi 2, phi 3 and alpha is given. Then you can easily calculate the value of R2 and R3. Once you have the value of R2, then how you can proceed? Because right now you have the value of R2. Now come to this part. So you have the value of R2. You can easily apply the Lami's here. So when you will apply the Lamy here, you can easily calculate the value of P. I am writing the expression in between P and R2 because you have the value of R2. So when you have the value of R2, then the forces between force angle between other two forces. So this angle is nothing but sine 90 plus phi 1. So this is sine 90 plus phi 1. R2 you have already calculated, and it is P divided by angle between other two forces. So when we will subtract phi 1 plus phi 2 plus alpha from 180, then you will get this angle. So this angle is what? This is sine 180 minus phi 1 plus phi 2 plus alpha, and in this way you can easily calculate the value of P. So whatever P you will calculate, this is the minimum P, this is the minimum P correspond to which this upper block, upper weight is just about to move upward. Fine. So this is the concept of waves. Is there any problem? So in most of the cases, because in gate problem, because as you know, this the problem can be little bit lengthy, but you will, when you will solve this problem two, 3 times, then you will know that by the trick or by frequent uses of these concept, you can easily solve this question within couple of minutes. Fine. So right now I'm taking one example on this concept, and after that we will start the new application part of friction, that is the exclusion. Is it okay? So are you interested to solve the problem? Okay, so right now I'm taking one problem here. So please, I am giving 3 minutes to you. So in that time, I will draw the free body diagram. So please try to solve that question with your own. Can we, yes is asking, sir, can we apply Newton's second law in this case? Yes, as I already told you that it is an equilibrium problem. And what do you understand by the equilibrium? In case of equilibrium, there is no acceleration of the body. And by the Newton's second law deals with the acceleration problem, F is equal to m into a. Since there is no acceleration, that means we cannot use the Newton's second law here. Is it okay? Okay, so right now I'm taking one problem. So this is the problem. Okay, so please note it down and try to solve this. And during that time, I will draw the free body diagram for this. And after that, I will start to answer this question. Fine. So please solve this question. And same type of problem you will get in your examination. Okay. So I am waiting for the answer. Anybody who have already solved this problem can message your answer here. Okay, so I'm going to solve the question here. As you know, in this case, this is the weight W. So I am drawing the free body diagram of this point O dash. So at this point, our force W is acting, and this is what? This is R3, and this is what? This is R2. So all the forces are coming towards the point. And what about this angle? So R2 is making an angle of phi2 plus alpha with the vertical. So I mentioned here, this is what? This is phi2 plus alpha. And this R3 is making an angle of phi3 with the horizontal. Phi3 with the horizontal. So this is angle is what? Nothing but it is phi3. Fine. And apart from this angle is 90. This is clear to, this is very clear, and this angle will be 90 minus phi3. So here one force and all the angles are given, then we can easily calculate R3 and R2. But you should have idea that in the question he is asking what he is asking. He is asking minimum horizontal force. And if you want to know the horizontal force only P, that means there is no requirement of value of R3. Then what we will do, we will apply the Lamy such that we will get the value of R2 only. And there should be one known value. That means we can write here W divided by sine 90 plus phi2 plus phi3 plus alpha. Is it okay? Equal to R2 divided by sine 90 minus phi. Is it okay? Now, what about the phi2 and phi3? As you can see here, assuming coefficient of friction between all the surfaces is 0.3. So, coefficient of friction, that means mu1 is equal to mu2 equal to mu3. Mu3 is equal to mu2. That means phi1 will be equal to phi2 will be equal to phi3. Is it okay? Then what will be the value of phi? So phi1 will be equal to tan inverse mu. Mu is what? That is 0.3. So when you will take the tan inverse, right now I am taking, so you will get 16.69. So this value you will get 16.69. So that means here phi to 16.69, this is 16.69. So alpha is given. How much alpha is given? Alpha is given 10 degree. Alpha is given 10 degree. So just put alpha is equal to 10. W is given 500 Newton. So from here you can easily calculate the value of R2. Can anybody tell me what is the value of R2? Anyone? How much value you are getting of R2? Just tell me. Please tell me what value of R2 you are getting. So Muhammad Jahid is saying 19, it is 1976.85. So all of you are getting this value only or anything different? Very good. So Nihant is already getting this value. That means R2 is equal to 1976.85. So I am finalizing this value of R2 now. Right now we have the value of R2. That means we can also do the analysis on this block also. So if we can do the analysis, that means we can get the value of P. So just apply the Lamy here. So how you can apply? Just draw the free body diagram of point P. So it is point P is acting like this, and R2 is acting like this. R1 is acting like this. R1 is acting like this. Fine. This is the horizontal line. Sorry, this is the vertical line. This is the horizontal line. What about the angle of R1? Contact force at 1 with the vertical. So it is given. This angle is what? This angle is phi 1. And what about this angle? So this angle is given phi 2 plus alpha. Phi 2 plus alpha. And this value is R2. This we have already calculated. This angle is 90. And what about this angle? So as you know, this angle is what? 180 minus phi 2 plus phi 1 plus alpha. And what about this angle? So this angle is 90. So how you can write? You can write in a way R2 divided by sine. R2 divided by sine 90 plus phi 1 equal to P divided by 1 sine. P divided by sine 180 minus phi 2 plus phi 1 plus alpha. Is it okay? Any doubt? Just tell me the answer. So yes is getting P is equal to 14.18. So let me check this because I didn't have the idea about the answer. Okay, so give me 1 minute. Okay, so it is in front of my desk. So answer is 1418.44. So what you will get? You will get P minimum is what? P minimum is equal to 1418.44. This is the answer only. All of you are getting this or not? Please respond. All of you are getting same answer or not? Yeah. Yes, your answer is correct. Very good. Mohammed, your answer is correct. So this is all about the wages. What you will have to do whenever you will find a question from the wages, first you have to draw the free body diagram, and after that most of the time you will get a problem related to the 3/4 member. So for a 3/4 member, you know the condition. What is the condition? That all the forces should, all the contact forces. Why? Because if we will consider N1, F1, N2, F2, then the body will be subjected to more than 3 forces. So in that condition, we have to resolve, and resolving the forces will take much more time. So it is very useful. It is very easy to make the system 3/4 member, and after that all the forces are passing through the same point. Just find out the angle, apply the Lamy, and you'll get the answer within 2 to 3 minutes. Hardly in 2 to 3 minutes you can solve such type of problem. Is it okay? Fine. So Harsh is saying, sir, explain once free body diagram, alpha value, how to write correctly. Okay, fine. So actually I think that Harsha, you are confused with this alpha term. Is it okay? Am I correct or not? I think that you are confusing with this term only. Fine. So how we are getting this? I am going to explain here why alpha is here. Why alpha is here, or the angle between the normal reaction is. So just see here, this is a simple trigonometric part. I hope this is clear to you that this is friction, this is normal reaction, and this is the contact force R1. So this angle will be what? This angle will be phi 1. I think this is clear to you, because the angle made by the contact force with the normal reaction is what? This is the angle of friction. Now see here. This is the friction. I don't think that there will be any doubt. This is the normal reaction. There should not be any doubt. This is the total contact force or the resultant, total contact force or the resultant. So this force is what? This force is nothing but R2, this is N2, and what about this? This angle is phi2. But you are confused that why this is alpha. So see here, this is a simple trigonometric part right now, because we are interested to know what is the angle made by the normal reaction with the vertical solid. We are interested to know what is the angle made by the normal reaction with the vertical. So as you know, if this is the normal, that means this will be the perpendicular. If this is perpendicular, this angle will be alpha. This angle will be alpha, and this angle will be 90. Is it okay? Or you may write like this: if this angle is alpha, then obviously this angle will be what? This angle will be alpha. As you know, this normal is making 90 degree with this 90 degree with this plane. That means this angle will be what? This angle will be 90 minus alpha. If this angle is 90 minus alpha, this is a horizontal, this is a vertical, then what about this angle? This will be alpha. So this is our simple trigonometric part. There is no big concept in this. Sir, why N2 is not considered? Prince is asking, sir, why not N2 is not considered? Prince, as you know, if you have studied the concept of friction, so what is the friction? This is the normal reaction. But friction when will act? Friction will act only when the surface is rough. Otherwise, normal reaction always act. So this is on N2. If the surface is rough, in that condition, a friction will also act. Sorry. In that condition, this is hanging. Wait a minute. Please wait a minute. Sorry, my OneNote is not working. Okay, fine. So see here, as you are saying, so whenever a surface is smooth, in that condition only this normal reaction acts. But if the surface is rough, in that condition a friction force also acts. So now what is the contact? Contact force is nothing but the resultant of these two forces. These two forces is what? One normal reaction and one friction force. So when we are considering that the total contact force, so total concept, when we are considering the total contact force, that is the resultant of N2 and F2, that's why we are considering. That means we can remove this N2. We can remove this N2. Why? Because you know the concept of resultant force. What resultant force is? Resultant force is that it will create the same effect as that of produced by those forces. So whatever effect is produced due to F2 and N2, the same will be produced due to R2. That's why I am not, sorry. So, okay. Okay. Sorry. Screen is not shared with you. Sorry, I am again explaining. Yes. Sorry, Prince. I didn't share the screen because my one note is stopped working. So I am again explaining here. Please listen it very carefully. That when the surface is smooth, in that condition you have only N2. I don't think that there will be any doubt. But when the surface is rough, in that condition you will also have one friction, F2. Now, what is the resultant of these two forces? So the resultant of these two forces is what? This is R2. And as per the definition of resultant, what is the definition of resultant? So it will produce the same effect as that of produced by the other forces. That means whatever effect is produced due to N2 and F2, same effect is being produced here with the help of R2. That means there is no need to consider right now F2 and N2. And what about the reaction force applied by the wall? Same thing is happening. Same thing is happening with the wall. Prince, you can see here. You can see here that in this condition, I considered the normal reaction due to the wall, and friction force. Why friction force? Because when the block is trying to move upward, the surface is rough, so the friction force will act downward. In this condition, the resultant of these two forces will be R3. That's why I consider R3 here. R3 will produce the same effect as that of produced by F3 and N3. Is there any problem? Fine. Okay, very good, Prince. So right now the concept of screw, the concept of wedge is over. Right now we are going to start the screw. Very interesting topic. So I hope there is no problem up to now with the concept of friction as well as the wedges. So now we will consider the screw jack. So what is the screw jack? So what is the screw jack? So screw jack is what? Here we are going to explain. So yes is asking, sir, please explain numerical on wedge with the rolling friction. Actually, yes, that is because rolling friction is already a deep concept, and as you can see that wedge, that the concept of wedge is also lengthy. So such a type of problem that are rolling, that a combination of rolling friction as well as the examination. And basically we are gate oriented, so here we will study about only those topics which are important, only those portions which are important for the perspective of gate examination. Is it okay? So we will right now we will start the screw jack. Okay. So now what is the screw jack? Can anybody tell me what is the screw jack? I hope you have listened this term screw jack already. Can anybody tell me what is the screw jack? Lifting loads. Very good. So Pawan is saying it is used for lifting load. Very good. So what is this screw jack? It is nothing but it is a device. It is a device that is used to lifting the loads, lifting the load with the help of small effort applied at end of lever. So basically screw jack is what? So screw jack is nothing but it is a device that is used to lift the heavy loads. It is used to lift the heavy load with the help of lever. I hope you have seen this screw jack type of mechanism in when we mostly change the tire of our car. So in that case, we use a device. What it did, it holds that portion, it holds that side of the car, and after the repairing of the tire, we again mount that tire onto the tire. So up to that time, it holds the total weight of the car on its own. Sorry, not total weight, that portion of the weight that is initially handled by that tire. So that total weight is transferred to that screw jack. So how we can lift that load? With the help of a small effort applied at the end of lever. So this is the screw jack. Now in this part, we will discuss about the simple screw jack. We will discuss about the simple screw jack. So as you know, we are interested in this, which type of problem you will find in the examination related to this topic. So most of the time you will find the problem in which it was asked that what is the amount of load, what is the amount of effort that is required to lift a certain amount of load. Fine. So he will always ask what is the magnitude of effort required, what is the magnitude of effort required to raise the load or to lower the load. Fine. So here we will start with the simple screw. So what is the simple screw? So right now I am showing here the diagram. So this is nothing but, sorry, I think it is not copy. So I hope it is visible to all of you. So this is nothing but, this is a screw jack. So it is a combination of a nut and screw. What is the nut? So this base is called as nut. This base is called as nut. And what about the screw? So this portion is known as the screw over which their load is placed. So load is placed here. This is the integral part of that screw, and at this head of the screw, a lever is attached. So basically we apply the tangential force on this lever here, and correspond to this effort P, we raise the load here. We raise or lower the load here. And on which concept it works? So it also works the concept of inclined plane problems. Inclined plane problems. So it also works on the concept of inclined plane problems or the equilibrium of inclined planes. Now, so as we are interested to calculate the effort required to raise the load, so here we will see one derivation for raising the load. In the same way, you can do the analysis for lowering the load. So for lowering the load, I will not derive the equation. This is your homework. You will derive the equation for lowering the load, but I will write down the expression. Here we will discuss about the efficiency of a screw jack. Here we will discuss about the self-locking screw and the overhauling screw. Is it okay? So yes is asking, sir, do there is possibility of C clamp numerical in exam? No. Yes. Because it is the part of engineering mechanics, and engineering mechanics is also a basic subject. So he wants to check your basics only. So either you will get a problem that is related to the simple screw only, or you may get a problem from the differential screw. But from the problem you may get from differential screw in very worst scenario, in very rare case. Fine. So here we will discuss about the simple screw. Now, so effort required to raise the load. To raise the load. Fine. Please give me one suggestion. is it important to drive the relation, or we can directly write the relation? If you want, then I can drive the relation. Otherwise, if you don't want, if you want to see how to solve the problem, then I can directly write the relation here. Just please tell me in comment box. If you are interested to drive the relation, then I can drive here. If you are not interested, then I can directly write the expression here. Please write. So Parth is saying directly write the explanation, and I am waiting for another responses. If you all are agree with this term, then I can write the expression here. So yes is also saying that problem directly. Okay, fine. So see here. Okay, so Vinay is also saying problem. So most of you are interested to know the expression only, and you want to know how we can apply the expression, because this derivation part is a very simple term, and you can, for that derivation part, you can go through your books. So it already as I already told you that it works on the principle of inclined plane problems. So with the same concept, you will find that the derivation is proved there. Fine. So right now I am here. Right now I am writing the expression for the load required to raise the load. So it is nothing but the expression is what? P is what? P always denote the effort, where effort apply at the end of lever. Just see here. P is what? P is what? P is nothing but P is the effort required at the end of lever. This is the P, and it is acting at a distance of L. Fine. So this is what this force P is the effort required at the end of lever. Now it is equal to D divided by 2L W tan phi plus alpha. Sorry, this is tan phi plus alpha. This is the relation. Okay, so this is the relation. Now I am explaining the terminology here. P is what? P is the effort required to raise the load. Make this thing mark here. Make this thing highlight. This is the expression for raising the load. Fine. So P is what? P is the effort required. P is what? P is effort required to raise the load. W is what? W is the load which is raised. W is the load which is raised. What about the phi? So phi is nothing but this is the angle of friction. Angle of friction. Angle of friction. Now what about the alpha? So alpha is nothing but angle of helix, or it is the helix angle. Helix. This is the helix angle, or you can say that angle of the threads. What angle the thread is making with the horizontal? So alpha is the helix angle. And what about the L? So L is nothing but the lever arm. Lever arm. And what is D? So this term is very important. This term is very important. So always remind this thing in your mind. D is what? This is what? This is the mean diameter. Because sometime in problem you will see that mean dia is not given. Mean diameter is not given. The outer diameter, that is D naught. This is outer diameter, also known as major diameter, also known as nominal diameter. Nominal diameter. And what about the DI? DI is also known as root diameter, core diameter, or minor diameter. Fine. So suppose if mean diameter is not given and outer and inner diameter is given, then how you can calculate the mean diameter? So how you can calculate the mean diameter? So mean diameter will be equal to outer plus inner divided by 2. So in this way you can calculate the mean diameter. Just calculate the mean diameter, put it here, you get the answer. So in most of the question, what you will get the mean diameter, W, helix angle. Sometimes you will not get the angle of friction, but the coefficient of friction is given, and as you know that the coefficient of friction is equal to the tangent of the angle of friction. So from here you can easily calculate the angle of friction. So this is the effort required to raise the load. Now if we are talking about the torque, required to raise the load, then what will be the value? Torque required to raise the load. So what is the torque required to raise the load? Just see here. Can anybody tell me what is the torque required to raise the load? Because we are applying P here. So about this axis, what can be the torque required? Can anybody tell me what is the answer here? What should be the expression? Because we have the value of P. So what should be the expression for torque required to raise the load? P into L. Very good, Kiran. So the torque is nothing but force. Force is acting in tangential direction to this lever. So it is at 90 degree. So force into perpendicular distance, that is nothing but P into L. So from here you will get So you will get torque. So torque required to raise the load is nothing but P into L. In the same way you can calculate the torque required to raise the load. Fine. Now see here, this is the torque required to raise the load. If we are interested to know torque required to lower the load, what amount of torque or force required to lower the load? So expression will be almost similar, only the difference will be this will be D by 2L W. This is tan phi minus alpha. Only the sign is different. This will be tan phi minus alpha. In the prior case it was tan phi plus alpha. Now, so this is all about the lower the load. Here you will get to know what is the self-locking screw. As you know, this amount of torque is required when you want to lower the load. When you want to lower the load, this amount of torque is required. So that means if a screw jack is lifting a load. The screw jack is lifting a load. Now what will happen? Suppose if you will remove the load, so what will happen in that condition? There may be a condition that it will automatically start to lower the load. So in that condition there will be chances of accident. So what will happen? Either you are raising the load or you are lowering the load. There should always be a requirement of load. Fine. So if it is automatically closing, when we remove the externally applied torque, or when we remove the externally applied effort, and if automatically it starts to lower the load, that type of screw jack is known as the overhauling screw. Just listen this point very carefully. What is the overhauling screw? Overhauling screw. So what is the condition of overhauling screw? If the screw automatically starts to lower the load, automatically starts to lower the load, when effort removed. So such type of screw jack is called as the overhauling screw. Now what happened? As you have observed that what we do when we changes the tire, we just apply some torque and raise the load. After that, what we will do? Is there any person who always hold that screw jack? No, there is no person. So all types of screw jack are self-locking. That means when we will remove the load, the screw jack will be in that condition only. Screw jack always will remain in that condition only. Suppose it is happening that when we are removing the load, the screw jack is automatically starts to lowering the load. Such screw is known as the overhauling screw. That means for such type of screw jack, there is no requirement of any torque or any effort. So if this value is 0 or negative, in that condition, that screw jack will be called as the overhauling screw. Then what will be the condition for overhauling screw? That means whenever this tan alpha, because D is always positive, L is always positive, load is always positive. So whenever phi is less than alpha, whenever phi is less than alpha, that means this value will be negative. That means the required torque to lower the load will be negative. In that condition, the screw will be overhauling. But if phi is greater than alpha, that means in all the cases when you will remove the load, it will not start to lower the load. When you will remove the load, it will not start to lower the load. So such type of screw is known as the self-locking screw. This is alpha. Fine. This is what, if phi is greater than alpha, so such a type of screw is known as the self-locking screw. Is it okay? Self-locking screw. So these are two conditions for identifying either the given screw is overhauling or it is self-locking screw. Fine. So by seeing these two terms only, we can conclude that given screw jack is a overhauling or self-locking screw. There is one more method to identify identifying the self-locking screw, that on the basis of efficiency. So I think for this session, time is almost exceeded. So we will sum up this session here, and in the next session we will discuss about the efficiency of screw jack and efficiency for self-locking screw. And after that we will solve problem. Later on we will discuss about the important portion belt and pulley drive, and later on in the last we will discuss the one more important topic, that is the Lagrange's function. Fine. So for the rest topic we will discuss the doubt in the next session. So next session I have already told you that is related to the problems on screw jack, belt and pulley, and about the Lagrange's equation. So please join that session also, and if you find that this session is helpful to you, so please share this with your friends also. Okay, thank you.